All right, today we are talking about systems of inequalities. This next unit is going to be over solving systems of equations and solving systems of inequalities. Essentially what a system of equations or system of inequalities is, the system part just means multiple are graphed on the same grid. So if I had a system of inequalities, I'm graphing not one inequality on the grid, now I'm graphing two of them at the same time. And the goal of a system of inequalities, or equations, is to find the solutions that they share. So with equations, you're looking where the two lines cross. That would be where the solutions that they share are. It's just the point where they cross. But a system of inequalities is going to be the place where the shaded regions overlap. And we'll explore that in just a second as we graph these two inequalities one at a time. So starting with the first one, y is greater than or equal to negative x plus 2, I am going to graph that one in the color red. You choose whatever color you want to use. If you have no colors, feel free to use just a pencil, but shade lightly. And I'll indicate when you should shade darkly in a bit. But just for now, if you want to use just one pencil, shade lightly.
How many colors?
3 colors probably, or just 2. 2 colors or 3. I'm going to use blue for the other one. And if you can imagine, you'll see in a second, that where the red is shaded and the blue is shaded, that would be purple. We'll see in a second. So I indicated for you to pick one set of colors. Green, yellow, and blue, red, blue, and purple, yellow, red, and orange. So one set of colors like that. Anyway, raise your hand if you can tell me, where should we start when we graph a line in slope-intercept form? What piece of information should I use to start my graph? Dylan?
The y-intercept.
The y-intercept. So my y-intercept is 2. So I'm going to graph my original point at y is 2, x is 0 on the y-axis. I'm going to use a closed circle because y is greater than or equal to negative x plus 2.
Does that matter how we shade it? Like, do you want it to shade it lightly with that one too?
The points don't matter, just the actual shading part, shade that lightly.
Okay.
Now we need to use our slope to get the rest of this line. What is the, raise your hand if you can tell me, what is the slope of this this line here? Prisha. Negative 1. Raise your hand if you can tell me another way of writing negative 1 so that I can better graph. Sam. Negative 1 over 1. So if I write my slope as negative 1 over 1, what does that highlight for me, Sam? Down 1 and right 1 is what I'm looking for, because the top number is my rise, the bottom number is my run, and that's why we like to write our slopes as fractions, because it helps highlight how to move my points across the grid. So because my rise is negative 1, I'm going to go down 1. Because my run is positive 1, I'm going to go right 1. Down 1, right 1, and now I have my second point. And we're going to continue this process, and I highly encourage you pay attention for how we graph these points, because you will be asked to graph on your own in a second. Down 1, right 1. Because my slope is negative 1, down 1, right 1. And we continue that until we reach the edge. We go back to the y-intercept and we reverse directions. Up 1, left 1. Up 1, left 1. Until we reach the edge. And then I'm going to use a solid or dashed line to connect these points. A solid line because y is greater than or equal to the line. So I can use a solid line here. So now we have our boundary line graphed. This is the part where we're going to shade this first inequality. Raise your hand if you can tell me, above or below the line, where should I shade? Above the line. So I'm going to shade lightly. If you're using pencils, definitely shade lightly so we can come to our conclusions properly. So, any point in the shaded region right now or on the line is a point that would satisfy that inequality, y is greater than or equal to negative x plus 2. So if I plugged in 5, 5, that point would make that inequality valid when I plug in 5 for x and 5 for y. Let's go ahead and plot the other one. Again, I'm going to do this one in blue. And again, I'm going to start at my y-intercept. Go ahead and see if you can guess where I'm going to plot my first point based on my y-intercept. Go ahead and look at your paper and see if you know where it's going to go. Okay? I'm going to plot my first point at negative 2. And I'm going to do an open circle because y is just less than, not equal to 2x minus 2. So now I see that my slope is 2, which I can write as 2 over 1. My rise is positive 2. My run is positive 1. Go ahead and try to use that slope right now to plot your next point. So I plotted my original point. Use my slope of 2 over 1 to try to guess what your next point is going to be. My slope is positive 2, so I'm going to go up 1, 2, and then I'm going to go right 1. And there is my next point, right here. We're going to continue that pattern. Up 1, 2, right 1. Up 1, 2, right 1. And those are all the points that I can fit on the grid. And now I'm going to reverse directions. Down 2, right 1. Or left 1, sorry. Down 2, left 1 that time. We just reversed both directions. And now, raise your hand if you can tell me. Will this line be dashed or solid? Go with Kiana. It is going to be dashed. And then raise your hand if you can tell me, after we dash the line, will I shade the region that is above or will I shade the region that is below? Below. It is below. So again, shade lightly below the line. And then especially if you're using pencil, shade darkly in the region that you already shaded. So you'll notice there's a region that had already been shaded the first time. Shade over that a little bit more darkly. To hopefully indicate where both inequalities are shaded. So now looking at the grid, maybe you notice both regions, or not both regions, maybe you notice that there are 4 distinct regions now. There is a region where there is no shading, there is a region where there's red shading, and there's a region where there's blue shading, and then there's a region where there's red and blue shading, theoretically purple shading. In the region that is blank, there is no shading. All of those points will not satisfy either inequality if I plug them in. So if I plugged in 0, 0, it would make the red inequality false, and it would make the blue inequality false. The region that's shaded in red, if I plugged that point in, it would only satisfy the red one. So if I plugged in, say, 0, 3, it would make the red inequality valid, but it would make the blue inequality invalid. The blue region, similarly, is only going to satisfy the blue inequality. But the purple region, there's some red shading and some blue shading. So all the points in that purple region will satisfy both inequalities if I plug them in. So if I plug in, raise your hand actually, and give me an example point that is in the purple region. A point that is in the purple region. Go with Sam. 4, 0 is a point in the purple region. Somebody want to give me another point? Because this is just a possible point. It's about 3, 1. Can I get another one? Go with Vanch. 3, 1. And we'll do, see, 6, 3. It's out of the region. And I like that you found one that's not even on the grid, but true. 6, 3 would be. Matthew? 2, 0. I like that you found one on the red line. That is another possible solution. Jenny? 5, 5. Thank you. And then one more from Naomi. 4, 2. Notice how there's a lot of possible points. In fact, there are infinitely many points. The solution set to these inequalities, the system of inequalities, is infinitely many points. It's just now a little bit limited because it's only where blue is shaded and red is shaded. But all of these points, if I plug them into these inequalities, it will satisfy them. And I'm going to do one example here. I'm going to plug in 2, 0. So 0 is y. Y is greater than or equal to negative 2 is x plus 2. Negative 2 plus 2. And then negative 2 plus 2 is 0. So is 0 greater than or equal to 0? Yes. So that is a valid solution for this inequality. Let's do the other inequality. Y is 0. X is 2. 2 times 2 is 4. 4 minus 2 is 2. Is 0 less than 2? Yes. So notice that this point satisfies both inequalities, and that's the idea. We are trying to find the solution set that satisfies both types or both examples of these inequalities, both inequalities in the system. And specifically, the points on the red line and in this purple shaded region are all points that satisfy that inequality. All the points on the red line in blue, and then all of this purple region. Okay, any questions about that? That is the goal for a system of inequality, is just to find either example points that will satisfy your system, or to find the entire region is shaded correctly, or all 4 regions are shaded correctly. One is blank, one is just one color, one is another color, and one region they share, and that is the solution set to the system. Okay, if there aren't any questions, then I'm going to go ahead and move on to the next example. This example says x is greater than negative 1. What kind of line is an x equals equation? Raise your hand if you can tell me what type of line an x equals equation is. Sam? It's vertical. If you haven't noticed, there's a yellowish poster in the back of the room to remind you horizontal lines are y equals equations, vertical lines are x equals equations. So at x equals negative 1, I'm going to draw a dashed line And this is the only time I will shade left versus right, is when I have a vertical line. So if x is greater than -1, do you think I'm going to shade on the left side or the right side? The right side, because everywhere on the right side are where my x's get bigger. So all of this on the right are my numbers that are bigger than -1, my x values that are bigger than -1. Let's do the same thing with my y equals equation, which this time my y equals equation is going to be in blue, and it's horizontal. Y equals -3 is my boundary line. But y is less than or equal to -3. So I'm going to shade below my line. And you can see that my solution set is all of this region where my x's are greater than -1, but my y's are less than or equal to -3. So one example point would be 0, -4. Okay, it's just another example point that would satisfy this system of inequalities. Take a look at where I'm pointing. Is this point a valid solution to the system? Yes. It's on the line and shaded in red. It's on a solid line. Is this point a valid solution to my system? No. It's shaded in blue, but it's on the dashed red line, so it is not a solution to both. It's just a solution to the blue. Okay. Any questions before I move on to the bottom left one? And then you will practice graphing the bottom right one. Okay, bottom left. Okay, again, we always start with my y-intercept of -1. My y-intercept of -1 is going to be a solid dot. My slope is also -1, which I can write as -1 over 1. So I can go down 1 because my rise is negative, I go down, and right 1 because my run is positive. Down 1, right 1. Down 1, right 1. Down 1, right 1. And those are all the points I can fit with that pattern. I'm going to go back to the start, go up 1, left 1. Up 1, left 1. And I'm going to continue that pattern until I reach the end. Now I'm going to connect it with a solid line. And I see that y is less than or equal to my boundary line, so I'm going to shade below. Let's do the same thing with the other line. I'm going to start at my y-intercept again. This time it's 3. And my slope is the same, -1. So I'm going to go down 1, right 1. And I've plotted all my points. Again, it's equals to, so I'm going to do a solid line. And this time, y is greater than or equal to my boundary line. So I'll shade above. Raise your hand if you notice anything interesting about this particular system. Kaiser. The middle space isn't filled out? Matthew? There's no region where both inequalities are shaded. There's a region that satisfies the red. There's a region that satisfies neither. and there's a region that satisfies only the blue. Raise your hand if you think you know what we should write down here for the solutions to the inequality. Lila? No possible solution, or we just write no solution. There's no solution to the system of inequalities. There's no point that's going to satisfy both of them. Doesn't matter what XY ordered pair I choose to plug in, it's not going to satisfy either of these two inequalities. Are there any questions about this? Okay, then we're going to go ahead and